Hello everyone. This video represents another circuit synthesis problem. In here, we have to construct the circuit diagram for following RC impedance function using the first form. The impedance function is given. We said RC is equal to S plus 1 over S times S plus 2. In here, we have to apply first form. In first form, we can use the partial fraction expansion. Before apply the first form, we have to check whether the given function is realizable or not. For that one, there are some general properties for passive RAC function. We have to check one by one for this given function. The first one is must be a rational function in S with real coefficient. You can see it is a function in S and there are real coefficient. Then first one is satisfied and second one is may not have poles or zeros in the right half S plane. For that one we have to find poles and zeros of the given function. If we find poles, we can obtain poles from the denominator. There are two poles, S equals 0 and S equal minus 2. And we can obtain zeros from the numerator. There is one pole at S equal minus 1. Now I plot poles and zero in the complex plane. This is real axis. This one is imaginary axis. And poles at the origin, one pole, and another pole at the minus 2. And zeros, there is one zero at minus 1. This is 0. In this plane, this is the right half this plane. You can see there are no any also zeros in the right half S plane. Then second one also satisfied. And third one is may not have multiple poles or zeros. You can see there are no any multiple poles or zeros. That means poles in same place and zeros in the same place. Then third one is satisfied. Fourth one is may not have the degree of the numerator and denominator differing by more than 1. In here, degree of the numerator is 1 and the degree of the denominator is 2. The difference is 1. Then fourth one also satisfied, differing by more than 1. Not have differing by more than 1. The difference is 1. Then this condition also satisfied. And fifth one is must have non-negative real part for all S equal j omega. For that one, we have to assign S equal j omega to the function and find the real part. The function is Z RC S plus 1 over S times S plus 2. Then S equal j omega Z RC j omega is equal to j omega plus 1 j omega times j omega plus 2. J omega plus 1 minus omega square plus 2j omega. To find the real part, we have to multiply both the numerator and denominator by complex conjugate of the denominator minus omega square minus 2j omega minus omega square minus 2j omega. From that one, we can obtain omega squared minus j omega to the power 3 plus 2j omega over omega 4 plus 4 omega square. When I consider real part of ZRC j omega, real part is this one, omega squared over omega to the power 4 plus 4 omega square. It is a positive and this is a non-negative. Then this condition also satisfied. And last one is must have positive and real residues for poles. For that one, we have to do the partial fraction expansion. For the first of all, also we have to find the partial fraction expansion. Now I will do the partial fraction expansion of for the function, given function s plus 1 over this times s plus 2. We can write the partial fraction expansion a over s plus b over s plus 2. Then s plus 1 is equal to a times s plus 2 plus b times s. If s equals 0, 1 is equal to 2a. Value of a is 1 over 2. If s equals to minus 2, minus 1 is equal to minus 2b. Value of b is also equal to 1 over 2. In here, residues means value of a and b. You can see value of a and b both are 1 over 2. Then all are positive and real. Then last condition also satisfied. Now we can see the given function is realizable. Then we can apply the first Foster form for this impedance function. Then partial fraction expansion, I can write again. ZRC S is equal to 1 over 2 S plus 1 over 2 S plus 2. Then 1 over 2S plus 1 over 2S plus 4 is the partial fraction expansion. Then we have to find what are the components given by each impedance part. This is Z1 and this one is Z2. First, I consider Z1 is equal to 1 over 2S. If I consider the capacitor with the value of C, impedance of the capacitor is 1 over Cs and admittance of the capacitor is Cs. And if I consider resistor, value of R, impedance of the resistor is R and admittance of the resistor is 1 over R. From these terms, the Z1 is equal to a capacitor. This will be a capacitor. The value of the capacitor is 2 farad. And then I consider Z2, it is equal to 1 over 2S plus 4. For this one, I consider the admittance value. Y2 is equal to 2s plus 4. The reciprocal of the impedance. Then this one is admittance A, admittance B, YA and YB. If I consider these admittance terms, YA is equal to a capacitor. This will be a capacitor. The value is 2 farad. This one is C1, this is C2. And this one is equal to, I can rearrange 1 over 1 over 4. The answer again is equal to 4. Then this one will be a resistor because there are no S term in this part. Value is 1 over 4. This will be a R1. These two admittance values are connected in parallel because of this plus mark. Then Y2 will be, there will be a two component, capacitor and resistor connected in parallel. This is C2 and R1. Then I can draw the final circuit of the given function. There is a capacitor C1 with 2 farad, and this one is Z1, and Z1 and Z2 are connected in series. C2 is 2 farad capacitor and R1 is 1 over 4. This one will be a Z2. Then we can get the total impedance from these two terminals. This will be the ZRC. Yes. This is the final circuit for the given RC function. And when we apply the first form, we can obtain this kind of circuit. It has two capacitors and one resistor. I hope you all are clear about this example. Thank you.